In the fourth video in this section, we're going to talk about even and odd trigonometric functions with no new vocabulary and no new theorems or rules. So the graphs of the 6 trigonometric functions suggest that cosine of x and secant of x are even functions because their graphs are symmetric about the y-axis, while the other 4 trigonometric functions are odd. So the other 4, those would be what? Sine, they would be cosecant, they would be tangent, and they would be cotangent. They're symmetric about what? The origin. Symmetric about the origin. And I would actually like to go take a look at a previous slide and just confirm this. So secant and cosecant are supposed to be even. The other 4 are supposed to be odd. We're going to travel back to slide 8 and take a look at the functions again. So let's see. Here is the cosine graph, and is it symmetric about the y-axis? It seems to be. If we were to fold along the y-axis, then we would have points that matched up. I agree with that. The other one that was supposed to be even was the secant function that's right below. And if we were to fold along the y-axis, then yeah, we would have points that matched up even on these branches that are further away. So these two were even. Now, the other 4 functions, sine, tangent, cosecant, and cotangent, were said to be odd because they have origin symmetry. Well, origin symmetry is the same as like 180-degree rotational symmetry. So if you can imagine a point being maybe up here, then you take a 180-degree turn and you end up down here. Or in other words, if this is the point x comma y, you also have a point negative x, negative y. So that would be origin symmetry. And I see it, yeah. And I see it here as well. I see it here, and I see it, yep, there. So all of these were said to be odd. Okay, so back to where we were on slide 14. 2 of them are even, and 4 of them are odd. So here's an example. Let's confirm or show that the cosine function is indeed even and the sine function is indeed odd. So to do this, I want to think back to what it means for a function to be even and what it means for a function to be odd without looking at the graphs. And for an even function, we should recall that if you plug negative x into the original function, what you get as an output is just the original function f of x. And then for an odd function, if we plug in negative x, the output becomes the opposite of the function negative f of x. So let's start with cosine, right? So we think about our unit circle again. Let's try that circle one more time. And there's a circle. And let's say we look at some angle theta. So here is our angle. And for that angle, here is a point x comma y so that intersects the circle. So what we want to do then is plug in negative x, or in this case, it's going to be negative. Let's see, we want to take the cosine function and plug in negative theta. Okay, so negative theta would be the same space, the same angle, but around the circle in another direction. So in the opposite direction, this would be negative theta there. So what are going to be the coordinates of this point where that terminal ray intersects the circle? Well, if this point was xy, won't this point share the same x value and then have a negative y value there? This is x, y, this would be x, negative y. All right, so let's think about the cosine again. That cosine ratio back from earlier in the notes or one of the previous videos was x over r, x over r. So here is the x value and here is the r value. We'll come in with another color to make that more clear. So there's x, here's r. Well, for the negative x or the negative theta, it's the same x value, And the radius of the circle hasn't changed. So that's just x over r again, which is what? That's the cosine function. So we've proved it. You plug in a negative theta, you get the same ratio, you end up with cosine theta. So that's even. What about for an odd function? Let's go to that one. So let's consider the same type of, well, I can draw a better circle than that. Let's do it in blue. Here is our circle. And here is going to be our angle. We're going to call it theta. It hits at x comma y. And we're going to plug in. So we start by plugging in negative theta. So that's going to come down here. This is going to be negative theta. It is going to intersect at the point x comma negative y, just like the previous circle. Now, let's think about the sine ratio. Was the sine ratio, it was y over r. So here's the y value. Here's the r value. So then for negative theta into the sine function, the r hasn't changed, but this will be negative y. Aha! So the sine ratio of, or the sine of negative theta is going to be a negative y over r. All right, well, y over r is sine. Stick a negative on the front. This is negative sine of theta. And hey, we proved it. F of the negative x is equal to negative f of x. Sine of negative theta is equal to negative sine of theta. Here's another example, finding trigonometric values. We want to find all the trigonometric values, so that would be all 6 trigonometric values of theta. If the sine of theta is negative 3 over 5 and tangent is negative. So to begin this question, I think the first thing we have to answer for ourselves is, what quadrant is this angle in? And I'm going to do a little diagram here. I suggest if you're taking notes on your own to also make this diagram. So we know the quadrants as quadrant 1, 2, 3, and 4. Usually call them in Roman numerals. In quadrant 1, this is the easy one. We have sine theta as positive. We have cosine theta as positive, and we have tangent theta as positive as well. And that makes sense because the x's and the y's and of course the r's are going to be positive in quadrant 1. In quadrant 2, we still have positive y values over here in quadrant 2. So that means the signs are still positive. However, everything in quadrant 2 is going to have a negative x value. If this is 0, 0 here at the origin, we're going to have negative x's, which means the cosine is going to be negative. So cosines are negative. And that then tells us that the tangents, which are the ratio of y over x, are going to be negative as well. All right, over in quadrant 3. So in quadrant 3, we're going to have signs that are negative because we're going backwards from, and we're going down from the origin. We're going to have cosines that are negative as well because we're going left from the origin. And that means that our tangents are going to be positive. Finally, for quadrant 4, we're going to have negative signs again because we're going down from our y value. Signs are negative, but we're going to have positive cosines. And that means for this one, we're going to have tangents that are negative. Now, with that in mind, we know the sine is negative and then the tangent of the angle is less than 0. So tangent's negative as well. Where do we have negative sines and negative tangents? That looks to me like quadrant 4, negative sines, negative tangents. So to begin this, I'm going to kind of sketch myself an angle in quadrant 4. Angle in quadrant 4, right? And I should probably do that in a new color. And here we are. And so I'm going to go ahead and complete this right angle. Here is theta. The sine is negative 3/5. So if the sine is negative 3/5, and I know that sine is opposite over hypotenuse, then the opposite would be -3. The hypotenuse would be 5. And we would just then need to figure out what this x value is, or you might call it the adjacent side in this right triangle from theta. And we can do that with the quadratic formula, which would tell us that adjacent side squared plus -3 squared equals 5 squared. So that would be this unknown squared plus 9 is 25. And then that would tell us that the unknown squared is 16, and that unknown must be 4. And in the fourth quadrant, the cosines, yep, those are positive. So I can just call that 4. Okay, so if that's 4, I have all three sides of this triangle. I can now find all of the trigonometric ratios. So we know that the sine of theta is -3/5. We were given that. The cosine of theta then would be 4/5. It would be the x value over the radius, x over r, or adjacent over hypotenuse. That's 4/5. The tangent of theta is going to be opposite over adjacent, or it's going to be y over x. So opposite -3/4. And then for the reciprocal functions, cosecant of theta will be, we can either go back to the triangle and get the ratios from there, or we just know that cosecant is the reciprocal of sine. So this is going to be -5/3. Secant theta is going to be 5/4. And the cotangent theta is going to be 4/5. So there we have some ideas about using the even and oddness of trigonometric function, talking about the signs of SIG and the positive or negativeness in each of the four quadrants, and using that to find more of the trigonometric values.